needed for this tutorial can be found on this orbot.com. Okay, you can use the search functionality. Okay, once you found those 4 digital assets, you can install them to your Houdini. Here I have a Houdini session. It's a new scene. When I go back to orbot.com, I can click on one of the assets to download this asset. Install the assets by clicking this button. Just click on Launch in Houdini. This will run another script called orbot URL handler. Allow that. That script will talk to your Houdini. And it will ask you, do you want to open the file in the new session or merge it into the current Houdini session? I would like to merge it to the current session. Then you will have a assets browser here. The assets you have just installed will appear here. Let's go back to orbot.com to install the rest of the digital assets. Next, let's install the Biped Orient joints. You can click here and you can click Launch in Houdini, Allow. It will talk to Houdini, merge it with current session. I have one more asset here. Then let's go back to orbot.com, go to Biped, add extra joints, download, launch in Houdini, allow to the current session. Then the last one is the Kevfx Biped Auto Rig, which is the main Auto Rig tool. This is one node to integrate all the functionality inside. Depending on your plan with your Houdini, you may want to go with different level. If you have a indie Houdini, you can purchase the indie version. If you have a commercial Houdini, you need to purchase the commercial assets. If you want to install the assets studio-wide, you can purchase the studio version. Then you can click the launch in Houdini to install it, or you can use the nodes here to install the assets manually into your Houdini. So I will just demo this function. Once you click allow, and I want merge to current session. So now I have all the digital assets I need installed. So let's go back to the network view, drop a geometry node. Because these 4 digital assets are sub-level digital assets, so you need to create a container for that. Name it Auto Rig Demo. And let's go inside the geometry node by double-clicking on it. And now you can press a tab key, start to type the names. KineFX. These are the assets we have installed just now. Let's drop a initial skeleton. It consists of central joints and the left-hand side joints. This is easier for us to fit this skeleton to the character we have. The joints are properly named as well. So if you want to display the names, there are multiple ways. Number 1, you can show the info of this node and click on the name point attribute to visualize the names. So let's right-click on the visualization icon. We have a name visualizer added. Let's click on this pencil icon, and instead of using color, we need to use marker to visualize our name attributes, which are strings. Close. If you feel the fonts are too small, you can press D key while your cursor is in the viewport. Press D key and go to the guides and look for the guide font and change it to large. Close the dialog. You can visualize the name of all the joints. Okay, so you can see that we have C_head joint, neck joints, spine joints, the leg joints, and shoulder, arm, and finger joints. If you don't want to see those names anymore, you can right-click on the visualizer, turn off the name visualization. Now we need to bring in our character so that we can fit this initial skeleton to our character. Okay, let me bring in this geometry. So drop a file node and let it to read a file which is inside my work directory, Auto Rig Demo. Inside there, I have a geo folder. Select this character 22 geo, accept, and display it. Alright, so this is the character for Houdini. 1 unit means 1 meter. If you don't want to see the checkered UV texture on the character, you can turn off this. So let's name this character model. So let's template display the character model and display our initial skeleton. And you can see that the skeleton is quite far from the character. Let's see how we can fit the joint to our character. To do that, let's connect a skeleton node here. So basically, this skeleton node will take the output skeleton from initial skeleton node, and we can modify those skeleton using this skeleton node. So let me make the viewport a little bit larger, easier for us to work. And select the skeleton node and move your cursor into the viewport, press enter. Or you can click on this show handle icon here. Once you have done that, you can see that you are in the create mode of the skeleton. But for us, we don't want to create any more new joints. So we will be just go to the modify mode. For the modify mode, we need to change the joint placement to be freehand. And also we need to turn on the tweak mode, the child compensation. That's where you want to move the joint, but you don't want to move the children joints. We will turn on this option when we need it. So now let's first go to the side view. To do that, you can press spacebar 4, go to the right viewport, move the joints to fit to your character. For example, now I move the head joint to here. Then I'm going to move the neck, but you may notice that when I move the neck, the head joint will also follow. You need to turn on the child compensate, so that when you move the neck, the child joint will not follow. Okay. The same thing, we're going to position our spine joints, the cock joint, the pelvis joint, the hip joint, the knee joint. We need to make sure that the leg are slightly bent, and the ankle joint should be somewhere here, and the ball joint and the toe joint. Press space 1 to go back to the perspective view. Now let's go to the front view to make sure that the leg joints are placed properly. Space 3, that will give you the front view. You need to right click on the joints, click on show handle. So this way you will be able to rotate the joint. Here we want to affect the children joint as well. So we need to turn off the child compensate. Then rotate the hip joint to position the rest of the children joints. Go back to the perspective view again to double check that if the toe joint is in the proper place. Apparently it's not, so let's move it. But currently the handle is slightly oriented this way. So we can press M key to let the handle to align to world. When you press M, handle is aligned to construction plane, aligned to component, aligned to object, aligned to world. Then we can move the joint. For example, for the ball joint, I can move it as well. Then we can work on the arm. Same thing. Let's click on the shoulder joint. While the handles are aligned to the world, we can just rotate around the z-axis. Press space 3 to the front view and turn on the child compensate to position the shoulder joints, the elbow joint. Turn off the child compensate to move the wrist and the whole hand joints. Here we need to make sure that the arm joints are roughly on the same plane horizontally. The top view of the arm is not perfect, so we need to go to the top view, which is space 2, and let's move the joints with child compensate on. Okay. Then for the wrist, I want to turn it off. So we also want to make sure that the two arm bones are slightly bent. Then we also make sure that the finger joints are in place. I think I'm done with this initial skeleton. And now, if you look at the joints, right, you don't see the orientation. So in order to see the orientation, you need to connect a rig post. Then now you can see the orientation of the joint. The orientation of the joints might not be perfect, so we need to orient them. So let's create a Kevfx orient joint node here. Okay. After this is done, You can reuse the rig pose to visualize the orientation. Okay, after the Orient joints, all the z-axis should be point at the child joint, and then the x-axis should be perpendicular to the plane that this joint formed. Okay, for example, the shoulder, elbow, and wrist joint form a plane, and then the x-axis should be perpendicular to the plane. Then let's drop Biped add extra joints. So let's connect this rig pose to take a look at the end result. So this node actually mirrored the left hand side joint to the right hand side. Also, we will add some extra joints here and there to make sure that the auto rig will work properly. So after the preparation, let's put this into a network box here. This will be our joints. Okay, so the joints is finished. Okay, before we rig the joints, I would like to assign some material to the model so that it's more interesting to work with. So let me create a material node. To rig the joint, you just need to drop one node, which is the Kevfx Biped Auto Rig node. So let's do that. After you drop the node, it takes a little while to rig all the joints with necessary controls. Okay, yeah. So when you display this node, you can see the joints are rigged. Okay, you can press Shift F1 to hide the hint. Okay, if you don't see the controls, that's probably because you are not in this show handle mode. So once you click here, you should be able to see all the controls. You can give a quick try by moving the AK wrist. So it's working now. So the rig is done, but it's not affecting the geometry. Drop down a joint capture by harmonic. This is a very good capture method. It will give you very organic and nice results, but it works with non-intersecting geometry only. So I will show you what I mean. If you connect the joint to the middle input, which is the capture pose, and connect the rigged skeleton to the third input, which is the animated pose, you should be able to capture. But it will give you an error saying that we cannot do because possibly due to intersecting geometry. And I figure out that for this geometry, the eyelashes and hair have a lot of intersecting geometries. So I would like to split the geometry into two, and I make this connection to the right. So the left hand side will be the geometry that cannot be captured by harmonic. What are the ones? Eyelashes and hair. These two group of geometry will go to the left side output, which will be captured using capture proximity. Again, you need to connect the skeleton to the middle input, and the third input is not a must. So that's that. So you have two capture nodes, and now we need to connect the final deform node, which is joint deform. We also need to merge the two capture results into one, then feed into the joint deform. Okay, now if you select the rig, I will put this into a network box as well. Give a color so that I know where to look for my rig. So if you select that in the viewport, you can interact with the controls and to drive the geometry. Okay, I'm just only testing the rig. I haven't tweaked the settings to fit the controls to the character nicely, but at least you can see that this rig is working. Alright, to reset the character to the default pose, you select the Auto Rig node and go to this gear icon and select Revert to Factory Default. Yeah, that's how you make the character back to default pose. Okay, let me show you how this rig will work with this character. First, from the parameter panel, you can see that the parameters are organized into tabs. The first one is the root and body. On the ground, there should be a red circle of a root control. So you can select this root control and press T to translate this root control, and you can press R to rotate it. And again, you can just press Enter to have this 2-in-1 handle for both translation and rotation. So that's the root control. While you are doing that, you can see that the values are changing on the parameters. So you can key in the parameters as well. For example, if I don't want to have any rotation, I can just key in zeros into this here. You are able to control the control settings as well. For example, if I want the root circle to be a different color, say yellow, and there's another body control as well. When you move the body control, you are not moving the root control, but you may wonder why you have this two controls, root and the body. That is because this rig have this feature to allow different control to be in different parent space. For example, if you go to the arm, left arm, you will note that the parent space for the arm controls are body space. You can change it to root. Okay, you can just type here. And now, when you move the body control, the left arm will not follow the body control anymore because it's in the root space. So it only follows the root. If you move the root, it will move everything together. But if you move the body, it will move everything except the left arm wrist control, which is under the root parent space. So if you want to change it back, you just type body. Now body will control everything so that you can do rotation of the body. Let's take a look at the functions of the second tab, which is for this head and neck rig. By default, I have this IK control of the head. Of course, you can rotate the controller. Also, you can switch from IK to FK. When you're fully in FK mode, the IK controls are hidden. So now you can rotate the FK control. Values are changing here. Of course, you can switch back and forth between IK and FK. And next functionality will be the parent space for the head. By default, the parent space will be the last spine joint. That's to make sure that when you move the spine, the head will follow. If you change the parent space to body, then when you move the spine, the head will not follow anymore. So let's change it back to C-spine 4 joint using the drop down menu here. Now let's reset. And let's take a look at the third tab, which is the cork, spine, and pelvis. For the spine rig, I have this spline AK curve. So you can control both ends of the AK spline curve. So if you move the top, head will follow. If you move the bottom, it will move the pelvis. Okay, you can see here. The top control is IK go and the bottom control is IK root. And also you can change the color to something you like, for example, blue. Also, you can select the pelvis control and control the pelvis. Alright, so let's move on to the next tab, arms. Okay, for the arm, you have clavicle control and arm controls. You can select the clavicle control and rotate the clavicle, which will affect the shoulder. So you can rotate up and down or front and back. Okay, the values are here. Same thing applies to the right clavicle as well. For the left arm, you also have IK and FK, K and FK blending. Alright, when it's fully FK, you can rotate the arms, you can rotate the shoulder, the elbow, and the wrist. And when you switch back to IK, you can use the IK control, which is green, to move the arm and rotate the wrist. And of course, you can blend between these two, IK and FK, And for the IK, you also have the elbow twist control, elbow arm twist control to control where the elbow is pointing at. And for the right arm, you have the same control independently. And for the arm control, by default, the parent space is body. Of course, you can change it to root, right? And when you move the body, the arm will not follow the body control anymore. But if you change it back to body, when you move the body control, if you move the arm, actually you can also change it to some other parent joints of the arm hierarchy. For example, the C-cog joint. Then you can move the arm to the central gravity area here. All right. Then because the IK wrist parent space is C-cog joint, then when you move the cog control, and then we'll move the wrist control as well. The right arm is still under the parent space of body, so it will not follow. Okay, so you have individual controls for different arm. Alright, so now let's take a look at the hand. So for the left hand, you have finger movement like, let's try the right hand. You have the finger movement like curl the thumb, and you can have functionality like curl the index finger, middle, ring, pinky. And by the way, if the orientation is bad, that could be because your skeleton doesn't have a good orientation. So you need to make sure that the orientation is good when you do your skeleton fitting here. Okay, for example, this finger here, apparently the rotation plane is in this direction, so that results in the bad result. So you can go back and fix, because everything is procedural. So let's continue to take a look at the controls. And you have an individual rotation multiplier for different joints. For example, when you curl the index finger, you want the first joint to be more than 80 degrees. Yeah, you can change that value. You can also have the control to spread the fingers. And of course, on top of that, after you have curled the fingers, you still have an individual joint control. Say I want to tweak the joints of index finger, you still can go here, or you can select the controls. Like say I want to select the index 3. I want it to rotate a little bit more or less. You can control that. So this individual joint rotation will be made on top of the finger movement to give you final controls. So that's the hand control. And for the legs, let's take a look at the left leg here. And by default, the parent space is body. And for the IK, of course, we can select the cuboid control and move the foot, which will drive the IK leg as well. Of course, you can rotate it as well. And the pivot point will be this edge of the cuboid. And by default, the pivot point might not be the best for your situation. If you want the pivot point to be at the bottom of the heel, you need to shift the cuboid control towards the back. So let's reset position to default. And let's go down to the reverse foot control and go to the offset. And let's change this value to be something like negative 0.04, so that the control is moving towards the back, and this edge is now aligned with the bottom of the heel. Okay, now if you rotate the foot, the rotation is correct. And this being the reverse foot, you can have the control of roll control. Of course, you can change the limit of ball bending. Okay, if you don't want that much, because the nature of this screw, change it to a little bit less until you start to rotate around the toe. Okay, you can also limit this as well, so that you have this result. Okay, this is much better than before. Okay, other than this, let's reset this roll control. Other than that, you can have an individual heel lift, ball lift, toe lift controls. You can have also the heel pivot rotation and the ball pivot rotation, the toe pivot. Of course, you can have the foot twist as well. For example, from the front view, you can have the foot twist as well. That's the reverse foot control. And again, for the whole leg, you can switch from IK to FK. Then you can just do normal FK control of rotating the hip, the knee, the ankle, yeah, the ball joint. Alright, you can also blend between IK and FK, same as the arm control. Alright, I think that's all the functionality of the Auto Rig. And if you feel the skin weight is not good for certain area, for example, for the arm, we can still fine tune the skin weight by we can drop a capture layer paint node here. In this mode, you can paint individual joints capture weight. So for example, let's paint the weight for the elbow and the lower arm joint 1 here. We can firstly change this visualize to only visualize the selected capture weight for the selected joints. Okay, so then we can select the joints. So you know that we are going to do the left elbow joint here. So in order to see the values of the capture weight properly, I can turn off the textures of the viewport. And now you'll be seeing this infrared visualize mode. Alright, so if we are painting the elbow joint, you select the capture layer paint and press enter in the viewport. If you don't see a circle brush, alright, you can use your middle mouse wheel to change the size of the brush. And as for the functionality, if you right click, you will see that left mouse button by default is paint. Middle mouse button is to smooth funnel. Okay, here I have 3 joints: elbow, lower arm 1, and the wrist. And if you look at elbow, the elbow shouldn't control this area. This area should be controlled by this lower arm 1 joint. Let's fix the elbow joint first. Let's start to paint some weight for the elbow joint. So because this area should be controlled by the elbow joints, right, something like that. Then you can also right click, change the left mouse button to smooth funnel. Right, you can smooth the result. Okay, and also you can switch to left lower arm 0. Then this joint should be controlling this area. So let me switch the left mouse button to paint and try to add skin weight to it. Alright, after you have done that, you can actually smooth the result. So now this arm twist should have a smooth transition. Okay, so let's go back to the default pose again. Alright, after you have painted on the left hand side, then if you look at the right lower arm, it's still with the default value. The left lower arm joint have the better value. So how to mirror the capture weight from one side to the other? You can drop a capture mirror node that we're going to specify from left everything to right everything. And now just to visualize the end result, you can drop another capture layer paint. And if you look at the same joint, say the R joint is selected. Okay, so this will be the final result for the R lower arm joint. Then this is the without. If you bypass this capture mirror, then you can see that this is the initial skin weight. This is the skin weight that you get from the left hand side. But this node, I don't need. And let's turn on the texture. And this will be our rig character with this auto rig system. Okay, so yeah, that's all.